Hi, Daneo and Tsepo, welcome. You can start with this question 4 that's on the board. Okay, and it is 6 o'clock, so we might as well get going. Maybe if you just want to put in the chat for me if you've written your paper 1 or your paper 2. I assume if you're here, you are still busy with your exam. So just let us know in the chat if you have written your paper 1 or your paper 2 or both. How did it go? You've written both paper 1 and paper 2, and your years, really, Claire. Well done. That's commitment. Well done. And how did it go? How did it go, really, Claire? Paper 1 was okay, yeah, but paper 2, yeah, paper 2 is the killer. Well, I'm glad you're here and that you're carrying on working with a view to finals. Anyone else written yet? Daneo, Karabo, Tsepo, you guys, have you written yet? I hope you guys can hear me. Daneo and Karabo and Tsepo, let us know if you wrote, then we can all commiserate together. And give Zwelihle some support because she's done the hard bit. She's done both. Now it's just finals. Asipe is here. Welcome. Danao, you're also saying paper 2. So you've also written both, but you're here. That's really good. Well done. Well done for persevering and sticking with the maths, even though you've written your prelims, because there is that big final that's ahead. Not so long from now, actually, on the 5th of November. I think it's like 8 weeks. Asipe, have you written? Let us know. Okay, so Karabo, you don't have to write prelims. Okay. Interesting. It's nice to hear what you are all doing and how it's all going. Asipe, let us know if you've written. Who else has joined, Luyando? Oh no, crying faces, Asipe. What was that, paper 1 or paper 2? Paper 2. Oh, so paper 2 is the difficult one. And those of you who are all saying paper 2, what about paper 2 is difficult? Is it the trigonometry? Is it the geometry? Is it the analytical? Just put it in the chat and then we can maybe start to address some of those issues. Hi, Rechamoditswe. Caitlin's also here, welcome. Okay, so trigonometry, Euclidean trigonometry. Okay, so there may be what we can do today, because no one submitted questions for today, so I just picked some questions from, if you're wondering what paper I've been going through, It's the supplementary paper from 2019. So the supplementary paper is the one, say something happened to you in December and you couldn't write, maybe you were sick or had family circumstances or something, then you can write the supplementary paper 6 months later, the next year. So that's the one that I've been working from. But I'm thinking maybe what we do tonight is I prepped this, this first question that's on functions. Functions and inverses, but then I prepped 2 more questions on trigonometry, just because no one else submitted questions. So maybe what we can do tonight is just maybe some trig. If everyone is having difficulty, then maybe that's just what we do tonight. Let me know if you're okay with it, if you want to do functions, or if we can just skip right ahead to trig. Asipa, you saying you were writing the 2020 backup paper. Okay, you happy to your... I didn't even know they did that. I had a backup paper, but it would make sense to have a backup. I guess what if the other one leaks? Oh, but didn't the 2020 paper leak? I think it did. Hey, Coco, I think last year's paper leaked. Yes, it did. Yeah, let's just hope for no leakages this year because it creates so much disruption. Okay, right. So if everyone's happy, we're just going to skip right ahead to trigonometry, which is this question 5. And yeah, please have a look. I'm going to give you about, let's see, let's take 5 minutes. Just have a look at the question so long. And just have a quick think about what you would do. Maybe start working it out if you're ready. And then in 5 minutes, we'll come back and we'll all look at it together. In the meantime, feel free to unmute yourself and ask me any question about this work and what we're doing here in trigonometry. Otherwise, you can just quietly work for about 5 minutes. It's great to see you all, and sorry the papers have been difficult. I know it is. But please submit questions for Wednesday if you've come across something interesting, something difficult. We had some really good questions last week. So please feel free to submit and email me. I'll put my email here again. But you can also submit it through the app. We will pick up on it. And for those of you who have written and are back here tonight, grinding it out, well done. Well done. Okay, so at about 12 minutes past 6, we'll check back and we'll start looking at these questions. By the way, if you've written your paper and you have a copy of your paper and there's something that you really want to ask about the paper that you've already written, please feel free to send that to me as well, and we can look at the question here together. That's also an option if you've got your paper and you were allowed to keep it. Just send us a pic and we can look at the questions here. That will be interesting.
Also, if you'd like to share a paper with your teachers, that wouldn't be a bad thing either.
Hi, Chado. I don't think we've seen you here before. Welcome. We're just doing question 5 for about another minute. Have a look so long. You've just joined. And then we're all going to look at it together. Okay, no worries, Chada. All good. Glad you could make it. Thank you. Okay, so what I think I'm actually going to do, because trig seems to be such a big area and it seems to really bug everyone and, you know, be such a difficult task, it seems, to everybody. I'm going to start by just summarizing the trigonometry that you actually need to know, because, and this is what I suggest if you didn't do this for your prelim, or your prelim is still coming, but your final is coming as well, make a summary of each section. Start off by just going through your textbook, or if you have a study guide or something that you use to study from for maths, answer series, whatever it is that you've got, just use that and make a summary, a one-pager that just summarizes what you need to know for the section. So I'm going to start by saying, well, the first thing I need to know for trigonometry is really the basics, right? I need to know that sine theta is opposite over hypotenuse. I need to know my SOHCAHTOA. Cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent, TOA. I need to know that. That's my 3 basics. Then, so I'm going right back to grade 10. Okay. This is what you learned. You started with SOHCAHTOA. Then you learned about the special angles. So you need to know your 3 basic ratios. Then you learned special angles. And for special angles, that is 30 degrees, 60 degrees, 45 degrees, 90, 0, 180, all of those. Now, these always involve no calculator. But it's a bit of a funny thing because you can use your calculator, but you have to not show that you're using your calculator. And the reason I say that is because you can go onto your calculator and say, what is sine of 30 degrees? And it will give you that it's a half. So you can, as long as you write a half and not 0.5 or any decimal, that's fine. So it is a little bit of cheating, not even really cheating. It's just basically being a little tricksy about it because you are using your calculator, but you're pretending you're not. I hope that makes sense. So special angles. Then a typical paper starts with a Pythagoras question. Pythagoras or Pythagoras or trig on the Cartesian plane. So that's, for instance, where you have a sketch like this, and you have an angle that's in a specific quadrant, and you have to make a 90-degree triangle. And this is an example of a Pythagoras question. And you have to, without a calculator, this is also no calculator, because you have to use a sketch. Use a sketch. And typically on a grade 12 paper, this is the first question, where it says use a sketch, or without a calculator, solve whatever question it is. Okay, so you have this is your minus x, this is your y, that's your r. So when you're on the Cartesian plane, now you have to use sine, cos, tan, but you have to use x, y, and r. So sine of theta is opposite over hypotenuse, so that's y over r. Cos is x over r, and tan theta is y over x. Adjacent over hypotenuse. Adjacent, TOA, opposite over adjacent. Yeah, that's right. Okay, so that's the Cartesian plane stuff. And always question one, typically, okay, unless one year they decide to change things up and then they do something different. Okay, the next question is normally where your grade 11 trig starts, reductions. And that is typically your cast diagram. So all stations to Cape Town, or, so this is theta, this is 180 minus theta. So here you have to know where each trig ratio is positive and negative, and then apply your reduction rules. So for instance, cos of 180 minus theta reduces to negative cos theta, because cos in the second quadrant is negative. So this is my first, second, third, fourth quadrant. Okay, along with your reduction formula, you have to know the co-ratio rules, or the 90-degree rule. So co-ratios, 90-degree rules. That means sine of 90 minus theta changes to cos theta, and cos of 90 minus theta changes to sine theta. So only when you are in the 90 minus or the 90 plus quadrant. So sine of 90 plus theta changes to cos theta, and sine of 90 minus theta is, I'm writing the same thing twice. Sorry about that. So cos of 90 plus theta is minus sine theta. Why is it minus sine theta? Because you always look, when you are applying the co-ratio or the 90-degree rule, you always look at the original function and if it's positive or negative in that quadrant. So for instance, the 90 minus theta quadrant is the same as the first quadrant. And the 90 plus quadrant is the same as the 180. It's the second quadrant. And cos in the second quadrant is negative. But in that quadrant, now if you're doing 90 plus theta, cos changes to sine. Now, this can be incredibly confusing, but these are rules that you just have to learn off by heart, okay? So if you're struggling with trigonometry, I would suggest that this is where you start revising and trying to get better at trigonometry, because this really is sort of the most important part of trigonometry, and you use it in your grade 12 trigonometry and in 3D trig, excuse me, 3D trig, when you're doing your trig equations, everything is about the reduction formula. So if you're struggling with trig, go right back to grade 11 and make sure that you understand this part here with the reductions, the 90-degree rules. And then there's also, I'm not going to write it all down because I really think you should make your own summary, but there's also negative angles and angles greater than 360 degrees. So you have to know the rules for all of that. And most textbooks will have this in, so you don't have to go look for it anywhere. Plus, our app has it on as well. Okay, our Watobi app, it's there too. So that is reductions. And that really is, you learned this in grade 11. And the biggest part of grade 11 trig was spent doing this. So if you ever feel like you got lost somewhere, that is likely where it happened. Because it's a lot to take in and you have to really, really practice it to get good at it. Okay, so if I look at our trig universe, this is where we are. So angles of 360, angles greater than 90. Okay, so that was up to grade 11. Then you came in grade 12. And I'm going to make it a different color just because now we're in grade 12. So in grade 12, you learned compound angles. Okay, and I'm also not going to write them down because of time and because they are 100% available to you in your textbook. And we've got a great section on the app, on the Watobi app, on compound angles. But that basically, those are the ones that says sine alpha plus beta. How do I know it's a compound angle? Because it's one angle plus another angle. It's a compound. It's two things put together to make an angle. So two different angle values making another one. And then sine alpha minus beta, cos alpha plus beta, cos alpha minus beta. So these are all identities and they are on your formula sheet. Okay, so of course, if you want to work fast, you can memorize them, but they are on your formula sheet. You don't have to memorize them. Okay, if you're struggling but they are on your formula sheet, so just learn where they are on your formula sheet because you do use them a lot. So that was our compound angles. And then in grade 12, you also learned the double angles. And that is sine of 2 alpha and cos of 2 alpha. Again, I'm not going to write everything down because this is also on your formula sheet. Okay, Now, any of these can be applied to a question on special angles or a question on Pythagoras and trig on the Cartesian plane. Those all go hand in hand. Okay, so you can get compound and double angles in grade 12 mixed up with, they love doing that with special angles, where they do something like cos 75 that you can break up into a compound angle of cos 45 plus 30, for instance. That's a question that often comes up. Okay, so now 75 is made up of two angles. That's why it's a compound. Okay, right. Whew. Trig is a big section, so I'm not surprised that people do struggle with it. Okay, now where should we go next? Let's do the grade 11 identities that you learned. And those ones were sine squared theta plus cos squared theta equals 1. And sine theta over cos theta equals tan theta. Okay, those are identities. You just have to learn them. And they are also on your formula sheet, by the way. Okay, so that is all of that. I just want to make sure you're not leaving anything out. Now we get to that's sort of what we call general trigonometry. That's the general trigonometry. Now I'm going to make another color. And the next thing you have to learn, whom by the sounds of it you all love, is trig graphs. Okay, so the trig graphs is really a few lessons on its own, but you basically have to just know what the different shifts mean. Also, if you feel like you've fell off the bus somewhere with trig graphs, go back to your grade 11 work and make sure you understand what each variable and change means. I'm just putting variables down. But if you have a trig function like tan, the number in front, that is the amplitude. And that is stretching the graph, so making it higher or making it lower, stretching, or I just say squashing it. Okay, so that's the amplitude. If you put something in front of the x, or whatever variable in front of the theta, if you put something in front of it, that is called your period change. And that means you're making more waves or making fewer waves. Okay. And you need to know the period. You have to know the period off by heart for each graph. For the sine graph, the cos graph, the tan graph. You have to know off by heart what the period for each of those are, so that when the period changes, you can work out what the new period is. Because you always go from the original graph and then you look at how it's changed. So your job is to go and just study. If you are really not great with trig graphs, go and study the basic ones and then start looking at how they change. When I say study the basic ones, you have to know the characteristics of each graph. We call them the mother graphs, the mother functions. It sounds a little bit like I'm swearing, the mother functions, but it's basically what the criteria, what the characteristics are when they're not changed, and then go from there. If we add something to x or subtract something, it's a shift left or right, and it's counterintuitive. So if we're adding, we're not moving it to the right, we're actually moving it to the left. And if we're subtracting something from x, we're not moving it to the left, we're moving it to the right. Okay. And then Q is a shift up or down. Okay. Now, again, when you make your summary, there's a lot of stuff that can go into this section on trig graphs. Unfortunately, I don't have the time to do all of it, but that is the gist of it. Okay. You have to know how each graphs change. You have to know how, what the original graph is, and then you really need to know your calculator. Because your calculator is your friend when it comes to trig graphs. You really can do a lot of it on your calculator. Drawing is on the calculator, and figuring out a lot of stuff you can do on the calculator. Okay, that's not the end of trig. The next part is the 2D trig. 2D trig. You see how big trig is, but if you're going to take it into bite-sized pieces like this, if you're just going to start somewhere and just make your way through, like I'm showing you now, it is going to become more manageable. Okay, so 2D trig, that is the sine rule, the cos rule, and the area rule. Okay, so that's like just solving triangles and finding the sides and the angles in triangles, and that again is also a few lessons on their own. But then comes the 3D trig with it, and that's just basically taking those three rules, sine rule, cos rule, area rule, and applying it in a 3D situation. I think on Wednesday, we can maybe do a 3D question. It is most certainly on the more complex and problem-solving part. So if you are struggling with time, or if you are, if you want to be smart about writing your exam, I would say the 3D trig is something that you can maybe leave till last, because sometimes it's a hit and a miss. You either see the solution and you can work it out, but sometimes it just doesn't go very well, and it can be quite difficult. Okay, that is all the trig that you have to know. Trig graphs, 2D, 3D, the grade 12 stuff, your identities, and then reduction formula, and using trig on the Cartesian plane. One big section that I think I want to add here, sort of on its own, is trig equations. And again, I really want to direct you towards the app, our app for this, because there is a really nice section on trig equations that's taught by a South African teacher, and it is really good. So trig equations, there's also a lot, and I think maybe that's also something for another day. But yeah, there's trig equations normally. So that is where you have your general solution. And that's where they normally mix it in. And that's, I think, is a good place to put it here with the trig graphs, because they normally mix it in with the trig graphs, and they say how, what is the general solution of the two functions. And that's basically the point of intersection. Okay. Let's get cracking on this one here, question 5. Now, you had some time to look at it. And like I said, typically, the paper will start with a Pythagoras question where you have to draw a diagram and solve without a calculator. This one doesn't actually. This one starts with, write the following expressions in terms of sine 11. Okay, what do we see? 11 is an acute angle. So that means both of these, well, sine 191 needs to be reduced. That's the whole point of reduction formula, is to reduce something from an obtuse angle to an acute angle. And to do that, you follow the rules of reduction formula. Okay, so 191 we can write as 180 plus 11. So your thought process is, where does 191 lie? It in which quadrant? So that would be here in the third quadrant, right? Over here. So we can say, what must I add to 180 to get 191? I'm adding because I'm in the third quadrant. Guess what? 11 degrees. Now you start thinking, oh, I'm on the right track here because 11 is what we are looking for. So 191 plus 11. But sine in the third quadrant is negative. So it reduces to negative sine 11 degrees. Who got that one right if you started the question and you had time? Who got that right? Just switch on the light. Anyone? Anyone got it right? Okay, great. CP, thank you. Okay, so now you must think. Now say you're writing this paper. Great, Chado. Say you're writing this paper. They've just asked a reduction formula question. That takes care of the grade 11 trigonometry. The double angle and the compound angle is the grade 12 stuff. It's coming. So you're ready for it because you know that they're going to ask it. Okay, guaranteed they're going to ask something to do with this stuff here. So next thing that comes is cos 22. Then you see, 11 is half of 22. So 11 times 22 is going to give you a double angle. So we can use a double angle to change cos 22 to have something to do with sine 11. So which one is it going to be? So if you look on your formula sheet or somewhere, if you have a textbook or something nearby, you'll see that cos 22, there's three options. Cos squared minus sine squared, 1 minus 2 sine squared, 2 cos squared minus 1. Those are all options for cos of a double angle. We're going to use 1 minus 2 sine squared 11 because that gives us what we want. Okay, who got that one right? Because this is the grade 12 stuff and it will definitely come up. So if you couldn't do 5.1.2, find your textbook and start going through questions where you have to rewrite angles in a double angle and in a compound angle, which is the next one, 5.2. Simplify cos x minus 180 plus root 2 sine x plus 45 to a single trig ratio. Okay, so we've got the reduction out the way, but it was an easy reduction. That was in 5.1.1. In 5.1.2, they asked the double angle. What haven't they asked? They haven't asked a compound angle, which is what this is here. That's a compound angle, and you're going to use the compound angle identity to expand that. What's going on here? X minus 180. Where is x minus 180? X minus 180 is in fact the third quadrant. Now, there's a trick you can do with anything that's funny or written like x minus 180, x minus 360, x minus 90. Anything that's written in the wrong order, not like 180 plus or 180 minus, you can add 360 degrees make it look more familiar, like something that you know. So cos, let me do it here. Cos x minus 180, you can say, well, I'm going to add 360 to it, and that is going to make it 180 plus x. And it's absolutely fine to do that, because if you just go around, you're going to end up in the same place. But you're just turning it into something that makes a bit more sense. Okay, so here's my answer that I did for 5.2. Cos 180 plus x is where this comes from. And then this sine x plus 45, here you just use your identity, your compound angle identity that's on your formula sheet, okay? And the way it works, if you're not sure, so the identity says sine of the first angle, cos of the second angle, plus cos of the first angle, sine of the second angle. Okay, so you just have to learn how that works, how to write it into the identity and how to expand it. Now it says here into a single trigonometric ratio. They probably intended for it to say no calculator. I would assume that this was without a calculator, because what you've got here is a special angle, Okay, so cos 180 plus x reduces to negative cos x. You change the cos 45 over here to 1 over root 2 and sine 45 to 1 over root 2. You can put that into your calculator and just write down, just make sure not to write down any sort of decimal. Just write down 1 over root 2 as a fraction. Then we bring the minus cos x down, and then we multiply the root 2 into the bracket. And that gives me, and again, if you're not great with doing this mentally, just do it on your calculator. Go root 2 times 1 over root 2 is going to give me 1. And root 2 times 1 over root 2 is going to give me 1. So that just leaves me with sine x cos x. And then the minus cos x plus cos x, they cancel, plus sine x. Okay, questions about that one, because that one is crucial. It is definitely a very good example of the type of question that will likely come up somewhere in your exam. Does anyone have a question about that? Let's clear it up right now so that you don't have to wonder about this anymore and that you're ready next time it comes up. Any questions?
Ma'am?
Yes. Yes, go ahead.
Oh, I was going to ask, can you just explain the second line again? I didn't hear. Because I got the, where I put the sin x cos x plus sin 45 plus cos 45. And then I'm a little bit confused as to why you put the 1 over square root 2 back when we separated them already. So
Okay.
the second line.
Okay, so the cos 45, that's a special angle. So you can just put into your calculator cos 45. That's why, yeah, so cos 45 is root 2 over 2 or 1 over square root 2. It works the same way, all right? So if your calculator is giving you root 2 over 2, you're going to get, I'll do that now. I think it will be hard to explain, but it is perfectly fine to put it as root 2 over 2 as well. But basically, you have to change it from cos 45 and sine 45, because those are special angles. Okay, so whenever you see a 30, 60, 45, you have to change it to the actual fraction values. So if you used root 2 over 2, that's fine too. And if you're now going to multiply it with that root 2 that's here in front, that needs to go into the bracket, this one here, then root 2 times root 2 is 2 over 2, and that is 1. So we arrive at the same place, even though, you know, it's using root 2 over 2. Okay, and then from the second line, Chado, you multiply in the root 2, and that's why it simplifies to sine x plus cos x over here. Any other questions?
Thank you.
Okay. I'll just say again, if you want to go look up these questions, this is June 2019. Okay, so if you want to have another look at them afterwards, you can watch the recording, or you can go to June 2019. It's the supplementary paper. Supplementary paper 2. They are all on the DBE website. If you're looking for papers, they're all there. You can even just Google this paper. Okay, so let's see what the time is like. Okay, so let's leave 5.3 for tonight. I think this is something you can look at on your own. 5.3, it is a complex question. Let's maybe work on something that's a lot of marks and will definitely be asked, and that's this question 6, the general solution. Okay, just take 2 minutes, think about what your strategy is going to be to solve this, and then we'll go over it. So at 10:02, I'll start going through it. Just have a general plan. You don't have to finish it. Just have a look at the question, think about what you're going to do, and then start it, but don't feel stressed to finish it. We'll look at it together at 10:02. Okay, so the first thing that we notice here is that we've got x minus 30 which is this here. It's a compound angle. So you have to use the compound angle identity to expand that. Okay. Very important. I'm saying this because I've seen many people make the mistake. And maybe you don't make that mistake, but I'm going to say it anyway. This cos x minus 30 does not mean cos x minus cos 30. Okay, that is not correct. I've seen a lot of people do that. And what you have to do is the expansion, okay? Because cos is a word. It is not a number that can be multiplied into a bracket, okay? It's not a word. It's a word. It's not a number or a variable. So the minute you see x minus 30, you think, okay, formula sheet, let me expand it. And this is how we're going to expand it. And again, it's just on your formula sheet. You write cos x cos 30 plus sine x sine 30. You just follow what's on your formula sheet. And that is equal to 2 sine x. Now, again, what pitches up here in this question, I don't know, this here for this paper, they really like these special angles, but they are the special angles. So do you see how important it is that you know your special angles and your compound angle identities and when to use them? So cos 30, you grab your calculator, you put that in. That gives me root 3 over 2. And sine 30 is a half. Okay, the only way you know to do that is because you must know that for all special angles, you have to write those values in. Okay. Now, we've got a sine x on this side and a half sine x on the left-hand side and a 2 sine x on the right-hand side. We're going to take it over to the other side. And that will give me 2 minus a half sine x, which is 3 over 2 sine x. Let's times by 2 to get rid of that fraction. Times by 2, times by 2. And now I'm left with, I'm just going to write this extra step in here, root 3 equal to 3 sine x. Just timesing by the 2 to get rid of the fraction. And then I divide by 3 on both sides. Oh, I've dropped my cos. I divide by 3 on both sides. And then divide by cos. How do I know to divide by cos? Because I can't solve an equation with a cos on the one side and the sine on the other side. Okay, so if you have a situation where it's cos x sine x, then you make a tan. But the important part is that the angles must be the same. If you have, this is why I say trig equations like another 5 lessons on its own. But this is just a little tip, one of Marielise's tips for trig equations. Sine x cos x, the only way you can solve it is to make a tan x. If it was cos A and sine B, now the angles are not the same. I'm going to make that and that. Then you have to use the 90-degree rule. So these are the two options that you can have if you have a sine and a cos. And how will we change that? Well, you can change cos to sine or sine to cos because they're co-functions of each other. You see why you need to go back and learn your reduction formula, because it all starts there. So I'm going to change cos to sine and make it sine 90 minus a is equal to sine e. Okay. Right. So that's just a little tip about sine and cos in equations. Back to our equation. So now we've made a tan. Tan x is equal to, sorry, yes, I did do that right, is root 3 over 3. So we do reference angle on the calculator. So you take your calculator and you say shift tan root 3 over 3 and you'll get 30 degrees. And because it's tan, we only have to do k times 30 degrees. So it's reference angle plus k times 180. And this is what the general solution is. General solution says I can take 30 degrees and add 180 any number of times. Once, twice, 3, however many. That's what this means. And I'm going to get this number here if I put it in for tan. Okay, so that is what the general solution is. And you have to write this bit here. K is an integer, k element z. If you don't, you lose the mark. Okay, so you have to write this here. It's not worth a mark. You don't actually get a mark for it, but if you don't write it, you lose the mark. You have to write that down. Okay, so that's trig equations. You see how everything's mixed in, and maybe that's why trig's hard, because we started off with having to do a compound angle for cos. Then we had a special angle that we had to write with its ratios. Then we had to solve an equation and know to make tan from sine and cos. Then we had to do our reference angle, and only then could we do our general solution. But as you work through past papers, this becomes much more familiar and easier to do. So you just have to keep working through the past papers. I did have this trig graph question prepared for you as well, but we can do that on Wednesday if there's time. Okay, any questions for now about what we've done so far? And please, for Wednesday, if you've got a question on trig, just send it in, please, and we can do it. Okay. Last call for a question, anyone, on what we just did? Okay, then I'm going to hand over to Coco, who's yawning.
It's been a very long day, ma'am. I'm sorry.
Yeah, we're still here at 7 o'clock doing maths.
Yes.
It's been a long day.
Oh, my goodness, my thing just closed on me. Okay. Hi, everyone. I just need to now reopen my page and get back to you guys. Please just give me a second. I will be with you guys in just a bit. My goodness, it's just disappeared. Okay. So we aren't really covering very much in this particular lesson, just that we are doing the Q&A. So we don't really have any questions or anything that we have to ask for you guys. We don't really have a set syllabus for you guys, but I was asked to ask you guys, just show of hands, or if you want to type in the chat, if you could invite one friend from school to come onto the live stream with you so they can see kind of what you guys see on this side. Not so much the live streaming, because when you live stream, they can't really ask any questions and they don't get the special attention that you guys do get. So just a show of hands, how many of you guys would like to invite a friend to come and join us for one Zoom class, to sit in this class with us? Okay, I've got one hand up. That's awesome. And Timothy and Asipe.
It's always nicer when you have friends with you, hey?
Yeah, and then they can get to see what you guys get to do on this side. And then maybe they will decide to stay, and then you guys can, compare notes and stuff at school, and you guys can get to see each other again on this side. On this side when you get here. Thank you so much, guys. Yes, Felicia, so we're just asking the question at the moment. So if you will get an invite to give to your friend, but remember, it is exactly one friend, so choose wisely. And we'll get that link to you guys as soon as we can, so you can invite that one friend. Okay. All right, guys, that's it from our side this evening. We're going to see you guys again on Wednesday at 6 p.m. Please do send in your questions so we can prepare in advance for you guys. And yeah, we'll see you guys same time, same place on Wednesday. Okay, bye everyone.
Well done, everybody. See you Wednesday. Bye.
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 Timothy, your profile picture is epic. I'm looking at it. I thought you were freeze framed. He looks so cool. Bye-bye, guys.
Bye, guys. Good luck.
It's a pleasure, Timothy. Bye-bye. We'll see you on Wednesday.